When sensor measures temperature or pressure, how does that information travel to PLC or control system? In this video, I'll explain the most common industrial signals like 4 to 20 mA, 0 to 10 volt and Modbus communication. In the previous module, we have learned about industrial process instruments like temperature, humidity, pressure level and flow. We also understood the control loop concept. Also, we have checked that sensors, then transmitter, controller and actuator. Now, the next important question is, how does a sensor communicate its measurement to the system? Because a sensor sitting inside a tank or pipe must somehow send the information to the control panel. And that is where instrument signals and communication systems come into the picture. Let us understand this with a very simple example. Imagine you have a temperature sensor inside a tank. The sensor measures the temperature, but the control panel may be 50 meters away. So, how will the temperature value reach to the control panel? The sensor must send a signal through a cable. This signal represents the measured value. This is called instrumentation signal. In industrial system, we use standard signals. Why? Because equipment from different manufacturers must work together. Let's take one example. Sensor from one company, transmitter from another company, controller from another company. If they all follow the same standard signal, the system works smoothly. That is why industrial automation uses standard signals like 4 to 20 mA, 0 to 10 volt and Modbus communication. Let's first understand analog signals. Analog signals change continuously with the measurement. For example, if the temperature increases, the signal also increases. The most common analog signals are 4 to 20 mA, 0 to 10 volt and millivolt signals. The most common signal used in every industry is 4 to 20 mA signal. Let us understand what this means. Imagine a temperature transmitter measuring temperature from 0 to 100 degrees Celsius in 4 to 20 mA signals. So here 0 degrees Celsius will transmit 4 to 20 mA signal. Like for 0 degrees Celsius it will show 4 mA and for 100 degrees Celsius it will show 20 mA. If temperature becomes 50 degrees Celsius, then the signal will around show 12 mA. So the signal always stays between 4 to 20 mA. There are several reasons why industry uses 4 to 20 mA signals. The first advantage is signal can travel long distance without disturbance. Second advantage is electrical noise has very little effect. And third advantage is if the wire breaks, the signal becomes 0 mA, which immediately shows a fault value. So 4 to 20 mA is very reliable for industrial environments. And that is why most transmitters convert sensor signals into 4 to 20 mA output. Now, another analog signal is 0 to 10 volts. In this system, 0 volt is equal to minimum value and the 10 volt is equal to maximum value. Now let's take one example. If temperature range is between 0 to 100 degrees Celsius, then 0 volt becomes 0 degrees Celsius and 10 volt becomes 100 degrees Celsius. But voltage signals are more sensitive to electrical noise. So they are less commonly used in heavy industrial environments. They are more common in HVAC systems and building automation. Now, some sensors directly produce millivolt signals. For example, thermocouple produces millivolt signals. But these signals are very small and cannot travel long distance. That is why we use transmitters to convert them into 4 to 20 mA signals. Now let's talk about digital communication system. Instead of sending only one signal value, Digital communication allows instruments to send multiple types of data. Let's take one example: temperature value, device status, calibration information, and sensor diagnostics. All this data can travel through a communication network. The most common digital protocol used in industry is Modbus. Modbus is one of the most widely used industrial communication protocol. It allows multiple instruments to communicate with each other. For example, temperature transmitters, humidity sensors, controllers, and PLC systems. All these devices can be connected through a single communication line. Instead of separate wires for each sensor, multiple devices share the same communication network. This reduces wiring and improves system efficiency. Most Modbus systems use RS485 communication. RS485 is a communication standard used for industrial networks. So main advantages of RS485 communication is it can travel long distance and support multiple devices. Also, it is very reliable in industrial environments. For example, you can connect 10 or 20 transmitters on the same RS485 network. All devices send data to the controller or computer. Another modern communication system is Modbus TCP IP. Instead of serial cables, it uses Ethernet networks. This allows instruments to connect to industrial computers, SCADA systems, and industrial networks. Many modern transmitters now supports Modbus TCP IP communication. In some applications, running cables is very difficult. For example, remote tanks, outdoor installations, very large plants. In such cases, wireless transmitters are used. Wireless transmitters sends data through radio signals. This allows engineers to monitor instruments without long wirings. Let us imagine a cold storage monitoring system. Temperature sensors are installed inside the cold storage. Each sensor connects to a temperature transmitter. The transmitter sends signals using RS485 Modbus communication. All the data reaches a central monitoring computer. Now, engineers can see temperature values on the screen. If the temperature goes above the limit, the system sends the alarm notification. This simple example of instrument communication in real industry. As a customer or as an application sales engineer, you must always understand what type of signal the customer needs or what type of signal I would use. For example, some systems require 4 to 20 milliampere signals, and some systems require Modbus communication, and some modern systems require Ethernet TCP IP communication. If you understand customer system architecture, you can recommend the correct instrument, or if you are the customer, then you would know which product is right for you. So, in this module, we learn what instrumentation signals are, why industries use standard signals, analog signals like 4 to 20 milliamperes, 0 to 10 volt, millivolt signals, also digital communications like Modbus RTU, RS485 communication, and Modbus TCP IP, and wireless communication. So, understanding instrumentation signal is very important for everyone who is dealing with the industry, because when you understand how instruments communicate, you can design better solution for your customer. Or if you are the customer, then you will understand what product to choose from. Now, in the next module, we will start exploring temperature measurement system, which is one of the most common industrial measurement. So thank you so much for watching. See you all in my next video.